Alkanes is a common term you will hear if you are in a organic chemistry class, and what it means is just a chain of hydrocarbons. So in this video, I'm going to do a chart on the basic from 1 to 10 number of carbon atoms in a linear alkane. So a linear alkane just means that there's no rings in it. And down at the bottom here, I'm just going to do a quick little side note. Linear alkanes, the way you figure out how many carbons or how many hydrogens there are in it is you just, so say you have C with an N amount, then you have H with 2N plus 2. So, an example of this would be if you have C2, you would have H 2 times 2 plus 2, which would equal C to the 2, H to the 4 plus 2 is 6. So that's how it is for everything. So if you had something like C to the 4, do a little example, C to the 4, then that means you have 10 hydrogens. So I'm also going to talk about the structural formula, the number of carbons, its formula, and then the state that it's in. So lighter alkanes would be in a gaseous state, and heavier ones are in a liquid state. So I'm going to start with methane. So we will do this whole column in red. So the formula for methane is CH4, so there's one carbon, and 4 hydrogens. So the number of carbons is obviously 1. And the structural formula is just CH4, and its state is gas. Okay, so that is an easy one. Next we're going to do ethane. So ethane has the formula C2H6, so that's like our example right here. The number of carbons it has is 2, obviously, because of this, so it's pretty easy to figure that out. And the structural formula is CH3CH3, and its state is still a gas. Next in line we have propane. So it has 3 carbons, C3H8, and it has 3 carbons like I just said. And the chemical formula is, this is where it gets a little more complicated, CH3, CH2, CH3. Now why does this have a 2? Well, when I show you in the next video what the actual linear alkane structure looks like, you can kind of see, if you know Lewis structures, that this carbon is going to be bonded to this carbon, and it's going to be bonded to this carbon, right? So these 2 carbons are only bonded to 1 carbon in the middle, which means that they have room for 3 hydrogens. So if I can actually just draw it right here. So if you have a carbon here that's bonded to a carbon and another carbon, this carbon only has room for 2 more bonds, because carbons can only have 4 bonds, whereas these ones have room for 3, right? So that's kind of the reason why this middle one is not a H3, it's just a CH2. So this propane is still in the gas state. Butane is next. So butane's formula is C4, 4H10, and the number of carbons obviously is 4, and the chemical formula is much like the one above, where it goes CH3, CH2, CH2, CH3, and its state is still a gas. So next in line we have pentane. So pentane is 5. So think about it like penta is 5, C5H12, and 5 carbons. So I'm going to start writing these now with just the outsides, and on the insides I'm just going to write, so I'm going to CH3, and then I'm just going to go CH2 to the 3. Oh, that's a bad 3. 3. Oh my god. This pen is hard to write with. CH3. And its state is a liquid. So this is the lightest, lightest liquid that we have. And it's the first time that the state is going to be a liquid. So 5 carbons causes it to be a liquid. Next we have hexane. So hexane is C6H14. It has 6 carbons, and it is CH3, CH2 to the 4, and CH3. And its state is a liquid, and it's going to be liquid from here on out, so I'm just going to write liquid all the way down here. That's the same. Okay, and then next we have heptane. So hepta is 7. So heptane is C7H16. So you can actually kind of see that these are just adding by 2s every time that this adds by 1. So it's fairly simple to keep track of that. And this is 7. And in here we have CH3, CH2 to the 5, and CH3. Next we have octane, which is 8. Octa is 8. C8H18 with 8 carbons. And the formula is CH3, CH2 to the 6, CH3. And once again is a liquid state. Next is nonane, which is 9, C9H20, and we have 9 carbons, and CH3, CH2 to the 7, and CH3. And the last one is decane. So we have 10 carbons, 22 hydrogens. We have 10 carbons, and the formula is CH3, CH2 to the 8, and CH3. So that is the basic naming formula and physical state at this is all at standard pressures and temperatures for chain alkynes, because the state can actually change if you change the pressure or the temperature, but this is just kind of a standard chart that is very useful for when you're drawing organic compounds that use these linear alkane chains. And it's important to understand that these different names here are based on, so I just think these ones you kind of need to memorize up until butane, and then after that penta is 5, hexa is 6, hepta is 7, octo is 8, nonane, nona is 9, and deca is 10. So it's important to know how many carbons there are in it, and from that you can kind of deduce the rest of the chart here. So that's it for this video. In the next video I'm going to talk about functional groups and how to actually draw chemical organic compounds with a few examples.